Good day and welcome to Waves and Optics. Before we start our lesson, let's have an icebreaker first. I have here a set of pictures and kindly help me identify what these are. Correct, that is light. Yes, that is prism. So how are these related to our lesson? Let's check it out to our objectives. Now, we all know that there are different colors as well as different colors of light. But did you know that these different colors of light are light waves having different frequencies? The frequency of red light is different from blue light and green light, or any other light. All these light of different frequencies make up the white light. Why? Because a white light is composed of millions of colors. Now the question is, can we separate white light? Yes, absolutely. We see in this picture that white light passes through a glass prism. Light then is separated into distinct color components. This process is also known as dispersion. An example of dispersion is a rainbow. So, what are the causes of dispersion? Number one, distinct wavelengths. Because each color's light has distinct wavelengths, white light disperses into seven colors. Red light has the longest wavelength in this range of seven colors, while violet light has the shortest. Next, space or medium. In a vacuum, all colors of light travel at the same speed. However, in any transparent material such as glass or water, various colors of light move at different rates. Velocity. Various colors light bend through different angles due to differences in their velocity. Red light travels the fastest through any transparent medium, whereas violet light travels the slowest. As a result, red light bends the least while violet light bends the most. Thus, the dispersion of white light into seven colors happens when various colored photons bend at different angles while passing through a glass prism.
Spectrum. It is the band of colors scattered by light entering a glass prism. Spectrum is the different wavelengths of energy produced by a light source, and it produces different perceptions of colors because it varies with wavelength or frequency. So each wavelength is associated with a distinct color. The color we see is a result of each of which wavelengths are reflected back to our eyes. Rainbow is the band of seven color formed by the scattered light. A rainbow is an example of white light dispersion. A rainbow is formed because of the high number of tiny droplets of water remain hanging in the air shortly after the rain. Each drop functions as a tiny prism. When sunlight strikes these droplets, the white light divides into seven distinct colors. A continuous band of seven colors is formed by the scattered light from a huge number of droplets. Rainbow is the name given to this colored band. There are seven colors of the rainbow, and these are the VIBGYOR, and this stands for violet, indigo, blue, green, yellow, orange, and red. One of the most nature's splendid masterpieces is the rainbow. Rainbows are the result of the refraction and reflection of light.
What is refraction? Refraction is defined as the bending of the path of a light wave, not just with light waves, as this also arises in sound, water, and other waves when it passes from one transparent substance into another or across the boundary separating two media. Why refraction occurs? Light refracts when it travels at an angle into a substance with a different refractive index or optical density. Therefore, it is caused by the change in speed experienced by a wave when it changes medium. As you can observe in the example, there is an illusion of a broken pencil in glass of water, where in fact the pencil is not separated or broken at all, which is a case occurrence of a refraction. Next is the reflection. It is referred to as light refraction when a light ray hits a polished, smooth surface and bounces back. The incident light rays hit the surface and reflect it off of it. The beam that returns is referred to as reflected ray. On a reflecting surface, a perpendicular would be considered normal. The refraction of an incident beam in a flattened mirror is depicted in the figure above. So the figure or the illustration somehow shows an imitation of a certain object or place. In the illustration, you can see that the bridge reflection is noticeable in the river and such occurrence is identified as reflection. It is a reflected application of an object that appears almost identical but is reversed in the direction perpendicular to the mirror surface. As an optical effect, it is results from reflection of substances such as a mirror or water.
Next is the law of refraction of light. Laws of refraction state that the incident ray, refracted ray, and the normal to the interface of two media at the point of incidence all lie on the same place. The ratio of the sine of the angle of incidence to the sine of angle of refraction is a constant. This is also known as Snell's law of refraction. These are essential especially in the waves of optics because without these, we cannot able to understand the behavior and light as well as the lenses and mirrors purpose. That would be all and thank you for listening.